The data shows us that population of 150 villages in the UK to the nearest 100. So the question is asking me to draw a histogram. So when you are drawing a histogram, you need to find the gaps. So when you want to find the gap, you would have realized that the class interval here is discontinuous. So when it is discontinuous, you will immediately go and locate your boundaries. So what's my boundary here? 850, 2050, 3250, 4850, and by logic, the first interval, because it's going by a gap of 50, the first one is a 50. So now what's my gap? My gap is 800, 400, 800, 1200, and this one is 1600. So using this, because the gap is not the same, you would have applied the frequency density formula and you will calculate all the values. The histogram is not a problem in this question now. So many of the students came and asked me, how do I find the greatest possible value of this interquartile range? And this is a population. Population means number of people. So they know that interquartile range is Q3 minus Q1. But this word here, greatest possible and then value. So how do I do this? Some of them were even logical to know that you take the upper boundary of the Q3 and you minus the lower boundary of the Q1, then you will be able to get the maximum value of the interquartile range. So what they did, they went and find the quartile 3. So what is the formula to find the Q3 or the Q1? Q1 is first 25% of your data set. So 25% is 1 over 4, and what is your sample size? It's 150 villages. So you're going to get 37.5 fifth data. You need to locate where is this. So if you want to locate the data, of course you will find the cumulative frequency. So what is my cumulative frequency here? 8. I have 8 villages, 20, 70, 118, and of course it should total up to the 150. So where is my 37.5th data? See, if I say I want to write it in the class interval, of course my answer will be 1300 to 2000. Similarly, when I do for the Q3, my Q3 is 75% of my whole data set. So I'll just take 3 and multiply, which leads to 112.5th data. And where is this? In which class interval? 2100 minus 3200. So what happens here, following the formula that we discussed earlier, if you want to find the maximum value of interquartile range, so what student did? They took the 3200 and then they minus the 1300, which gave them an answer of 1900. Okay, this one if you are using the class interval, but then you should realize when you were drawing the histogram, boundary was a matter for you, so you should have been alert. Correct? You can't just take the class intervals and come up to a decision saying 1900 is the maximum value. Why? Because there is a gap in between them. So what you did, you went and converted everything to this new population here, and that's what you use in order to draw your histograms x-axis. So not a problem, but now I am locating for a value. So I know that this is my Q1's interval and this is my Q3. So can I just take the 3250 and minus the 1250 now? So if I do that, what will I get? I'll get 2000. So is this 2000 correct? So previously we got 1900. Now if I consider the class boundaries, I'm getting 2000. Am I making sense to my solution? See, it is very important to consider what kind of data you are getting. human data. It means you are talking about number of people. So in the number of people, by logic, you look at this value here, can the upper bound, you see here, my upper bound here is 2050 and my lower bound here is 2050. Can I have 2050 people in two intervals at the same time? Of course, the logic doesn't make sense. So how do you actually write these new intervals so that you are more careful? So what you should do, you should be taking, let's say in the first village, the consideration here, so I could say I have 50 people up till 849, so that the 850 inclusively belongs to the second class interval. Then you could say that here you have 1 to 49, and this one is going to be 1 to 50 until 2049. Okay, let me just put a P, otherwise it looks awkward. Yeah, P for population, 2050, and this one is 3 to 49, and then so on. Now let's check whether the 2000 is realistic, or I should actually be doing some logic and take 3 to 49 and minus the 1 to 50. So if you do 3 to 49 and minus the 1 to 50, you will end up with 1999, which makes more sense to the solution.